we're going to look at another constrained optimization problem. So the first example we looked at was maximizing a function subject to a constraint. Now we're going to look to minimize a function subject to a constraint. Now one thing you'll note is that with the minimization, the constraint, the left-hand side will be greater or equal to the right-hand side. So let's see if we can work through and solve this out. So there we have our f of xy. So I'm going to go right here. I'm going to have x and y. Highlight those. And now I have my f of x. Y. So f of xy is equal to 5 times x squared minus 2 times x times y plus 8 times y squared. Now if I just use solver to optimize this function, well, I actually don't want to take a screenshot, thanks. Now I'm going to set my objective of f of xy and to minimize it by changing f of x and y. And then you'll see that to minimize, I just produce 0 of each. So that's not a very interesting-ish question. So that's why when we look at our minimization problem, we want to think, well, if we set x and y both equal to 0, that's our minimum, but we have now this constraint that we need to produce at least 60 of x and or y. So now we need to add a left-hand side constraint and a right-hand side constraint. Whoa. There we go. This might look a little better. Okay, our left-hand side constraint is equal to x plus y, and our right-hand side constraint is 60. So now when I go into solver, I'm going to add the constraint that my left-hand side is greater than or equal to my right-hand side. Now I click solve, and now I've satisfied that equation. So 36 is the amount of x and 24 is the amount of y. That will minimize f of xy, yet still satisfy the constraint that we produce at least 60 units.